Hello everyone, welcome back to our channel. We are back again with new video. In this video we are going to create a torus knot pattern using Python. So firstly we'll install the required libraries. So here numpy is used for numerical calculation and to generate the array of angles theta for the parametric equation, and matplotlib.pyplot is used to plot the 3D torus knot, and MPL toolkit, this is necessary tool to create 3D plot in matplotlib. And to create this, now we'll define parameters. So here capital R, the radius of the central circle of the torus. This determines the distance from the center of the hole to the center of the tube. And small r, the radius of the tube itself, and this controls the thickness of the torus. And P and Q, these are the parameters that determine how many times the knot will wind around the tube and the hole of the torus. And P is the number of times the knot winds around the tube of the torus, and Q is the number of times the knot winds around the central hole of the torus. So in this case the values are set as P is equals to 2, so the knot will loop around the tube 2 times, and Q is equals to 3, the knot will loop around the hole 3 times. So here theta is the angle parameter that will range from 0 to 2 pi, which represent one full rotation around the circle. And the np.linspace, this generates 1000 evenly spaced values between 0 and 2 pi, which will be used to plot the curve. Now we'll create a parametric equation for the torus knot. So here the 3D coordinate x, y and z are computed using parametric equation, and these equations define the position of each point on the knot. So here x coordinate is x theta is equals to r plus r cos theta dot cos p into theta. So this equation describes the horizontal position of the point as it winds around the torus. And y coordinate is the y theta is equals to r plus r cos theta into sine theta into p. So this equation describes the vertical position of the point complementing the x coordinate to form the loop around the torus. And here the next equation is for z coordinate, which is z theta is equals to r into sine q into theta. So this equation determines the height of the point relative to the horizontal plane, and it ensures the knots winding around the whole of the torus. And now we'll plot the torus point. So here figure is equals to plt.figure. This creates a figure of size 6 into 6 inches to hold the plot, and ax is equals to figure dot add subplot. This creates a 3D axis object where and adds a 3D subplot to the figure. The projection is equals to 3D argument specifies that the axis should be 3-dimensional.